The most common mistake is jumping straight to a bad controller. If the display turns on but the bike will not drive, that only tells you the control path failed somewhere. It could be a loose connector, a cutoff input, a battery supply issue, or the controller itself. So before buying parts, treat this as a symptom, not a verdict. Think of the e-bike as a chain that has to agree at every link. The battery has to supply power. The BMS has to allow it. The controller has to accept the inputs. The display, brake cutoff, throttle or pedal sensor, wiring, and motor all have to line up too. If one link breaks, the bike can look dead, even when only one small part failed. Now follow the ride command like a signal path. You press the throttle or start pedaling. That message reaches the controller, and the controller decides whether to send power onward. If the display says one thing and the motor response says another, the problem is somewhere between the command and the controller's response. That is why the path matters before the part name. The controller does not just wake up and drive the motor. It needs clean power first. Then it needs valid input from the bike's controls. It also has to see that no safety cutoff is active. Only after that does it send current to the motor. So the controller is part of a permission chain, not a single switch that works by itself. In a normal system, the command moves cleanly from the rider input to the controller, then out to the motor. In a fault, the flow stops early. It may stop at the input, a wire, the battery supply, or the controller output. That difference is the key. A no-assist bike does not automatically mean a failed controller. It means one part of the chain is blocking the flow. Before you blame electronics, inspect the connectors. A loose plug, moisture, corrosion, or a connector that is only partly seated can imitate a bad controller very well. Look for bent pins, grime, or heat damage at the contact points. If the connection is unstable, the controller may be fine and still never receive the signal or power it needs to operate. Here's the next trap. A controller symptom can start with battery supply. If the pack is weak, disconnected, or being limited by protection, the controller may look like the problem even when it is not. That is why supply has to be checked before replacement. The controller cannot drive the motor if the battery path is already interrupted. Inside the battery, the BMS acts like a gate. When it allows current, the controller can receive power. When it blocks current for protection, the bike can lose assist even though the controller is still installed and intact. So if protection has shut the supply down, swapping the controller will not fix the real cause. The battery side has to be cleared first. A tiny input can block the whole ride. If a brake cutoff is stuck active, the controller may refuse to send motor power on purpose. A throttle or pedal input fault can do the same thing by never giving a valid command. Check the input path, but do not bypass safety parts as a test unless you are following the bike maker's instructions and you know exactly what you are doing. The display and the bike's behavior give you clues about which branch is more likely. A clean power-up with no throttle response points one way. Intermittent assist points another. Sudden cutouts suggest a different path again. If the display shows a warning or error, that matters too, because it can narrow the system that is failing. The symptom pattern is information, not just annoyance. Now make the fork in the road. If power is unstable, look toward the battery supply. If inputs are missing, look toward the throttle, pedal sensor, or brake cutoff. If wiring is damaged, the signal may never reach the controller cleanly. If all the inputs look right but output still never reaches the motor, then the controller becomes a stronger suspect. That is how evidence separates the branches. One more contact point matters: how the battery seats on the bike. Even if the pack itself is charged, a poor rail connection or a dirty contact surface can interrupt power to the controller. That can look exactly like an electronics failure. So check the bike side contacts too. A problem at the seat can stop the whole system before the controller ever gets a stable supply. This is where people waste money. They buy a controller first because the symptoms feel electrical, but if the signal path or supply path was never confirmed, the new part may not change anything. A controller replacement only makes sense after you have evidence that the battery, connectors, inputs, and wiring are not the real blocker. Otherwise, you are guessing with a costly part. There is also a clear stop line. If you see melted insulation, burnt connectors, exposed conductors, or signs of heat damage, stop the home diagnosis. That is no longer a simple symptom check. A damaged wire can create resistance, shorts, or intermittent failure, and those can make the controller path unsafe. At that point, the right move is professional inspection, not deeper trial and error. Keep in mind that the same control logic can be arranged very differently from bike to bike. On one model, the controller may sit near the battery. On another, the sensor path may be routed elsewhere. The parts change shape, but the logic is the same. Supply, inputs, controller, and motor have to agree. So the layout changes, but the diagnostic order stays familiar. At this point, pick the next check from the evidence you have. If the connector looks weak, Inspect the connector path. If the battery seems unstable, confirm supply and seating. If the inputs do not behave correctly, focus on throttle, brake cutoff, or throttle sensing. If everything outside looks normal, but the motor still refuses to respond, that is when professional verification becomes the practical next step. The order to remember is simple. First comes the symptom, then comes the control path. Then you do the safe external checks. After that, you read the input clues and follow the decision fork. If you see damage, heat, or anything unsafe, stop there. That sequence keeps you from replacing the wrong part before you know where the failure actually is. If you want the full checklist, use the related guide for the complete symptom breakdown and step-by-step troubleshooting path. https://ebikedelight.com, Common Symptoms of Electric Bike Controller Issues. The main idea is to follow the evidence, not the guess. That saves time, avoids unnecessary part swaps, and helps you decide whether the controller is really the problem or just one link in the chain.